Assalamualaikum and a very good afternoon. First of all, I would like to thank all participants for joining this webinar with the title of Home Energy Management Systems in Future Smart Grid. This webinar is broadcasted live on IEEE PES Malaysia YouTube channel and Facebook platform. This webinar is organized by IEEE Power and Energy Society PES Malaysia and co-organized by IEEE UiTM Student Branch. I am Shakira from IEEE University Technology Mara UiTM Student Branch, and I will be the MC for this session. Our speaker is Professor Hussein Sharif from the Department of Electrical Engineering, United Arab Emirates University, UAE. He will be giving the talk on home energy management systems in future smart grid. Before I pass the session to our speaker, I would like to inform you that if you have any questions regarding the discussed topic, you can type your questions in the YouTube or Facebook chat box. I will post the questions to the speaker during the Q&A session. First of all, I would like to invite Associate Professor Engineer Dr. Ahmad Farid Abidin, Committee Member of the IEEE Power and Energy Society Malaysia, to introduce IEEE and IEEE PES to all of you. Dr. Farid, to you.
Okay, I'll put Dr. Farid. Okay.
Tak boleh kan? Boleh start ke? Dah start
Yes, Dr. Farid, you can start now.
Okay, sorry. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. Okay, please allow me for a few minutes to share or to introduce IEEE Power Engineering Society. So, okay, the first slide as we look at IEEE Power and Engineering Society, who we are and where we are going. IEEE is the world's largest professional association advancing technology for humanity, and it reached in terms of more than 400,000 members within 160 countries, more than 160 countries, more than 100,000 students member, and almost 2,000 annual conference. In terms of technical breadth, IEEE provide the technical document 4.5 million and 200 plus top cited protocols, 1,200 300 active standards and 49 technical societies. If you look to the social impact, we do have the public policy engagements, global humanitarian efforts, education and certification, as well as ethics in technology. PES is well known as the second largest technical society in IEEE. Okay, we have 45% IEEE standard, which is created under Power Engineering Societies. And how the IEEE Power and Energy Society membership can help you. Okay, by joining us as a member under IEEE PES, we can have a grow and maintain our technical expertise and get connected to other professionals in the particular area, contribute to the future of power and energy, as well as save the monies on valuable program and materials. And stay technically proficient with the PES. Okay, we have online webinar tutorials, on-site training and workshop, practice-oriented technical journal, plain taught basic courses for industry novice. And PES is deploying significant resources for training and lifelong learning activities for our practicing engineer. And many resources are eligible for us. And if we look to our resource center, okay, there is more than 1,400 items. The most extensive library for content in world devoted exclusively the field of power as well as energy. So you can find in one place, in one platform, such as tutorials, videos, technical reports, journal articles, archive webinars, conference slides, and many more technical materials are available in our resource center. Okay, looking to our global engagement through a local chapter. Okay, we have a region 1 to 7, region 9, region 8, and region 10, where Malaysia are in region 10 with 45 chapters and 9,375 members. Okay, here the list of the leadership PES Malaysia. So we are being established since 1994, and our current chair head by Prof. Hasli. Okay, what we did, what is the activity that we conduct under PES? Okay, we do have invited lecturers, conferences, award for outstanding engineer, networking and linking with industries, technical activities, final year project awards based on the competitions, okay, reaching out to members and senior member drive. Okay, please, we invite all the participants who are not being our member, let's become our members. And there is a free PES student membership, okay, for 1 year only. Okay, why become a PES student member? There is a benefit that we have available here, okay, to enjoy a free subscription to the PES award-winning Power Engineering magazine, to gain free access to the PES Resource Center with hundreds of technical reports, tutorial, video, and presentation as the one I've mentioned before. Okay, to receive free membership in local PES chapter, okay, receive discount at dozens of PES sponsored or co-sponsored conferences and meetings in your area as well as around the globe. And to take the advantage of discount of technical tutorials, utilize PES Careers, which is a free service designed to specifically assist and facilitate undergrad as well as graduate engineer students connect with employers in power and energy industry. Okay, join me as we bring more power to the futures. Okay, here there is a contact, email contact, and there is a website that you can browse and have a look what activity that we have done as well as the Facebook. Okay, this is the face of happy face for our technical committee, our committee. Okay, thank you. Over to you, Shakira.
Thank you, Dr. Farid, for the introduction to IEEE and IEEE PES. We hope that those who have yet to register as IEEE member, please join us as you will get all the benefits mentioned by Dr. Farid just now. Now, it is time for the main agenda. Let me introduce our speaker for this webinar. Prof. Hussein Sharif is currently a professor at the Department of Electrical Engineering, United Arab Emirates University, UAE. His current research interests are power quality, artificial intelligence, renewable energy, energy management system, and power system distribution automation. He is a member of IEEE. He has received a number of awards for his innovative research in ITES, ICC, UKM, and UAEU, and published more than 390 research papers in peer-reviewed international journals and conferences. With the introduction just now, I would like to call Prof. Hussein Sharif to give talk on home energy management system in future smart grid. Prof. Hussein, to you.
Thank you very much, Shakira. And first of all, I would like to thank IEEE PES Malaysia's chapter for inviting me and giving me an opportunity to give this talk. Today's presentation title is Home Energy Management Systems in Future Smart Grids. So I would like to show my presentation outline. first of all, I will give a background why energy management is important, and then I will try to give how the home energy management, or in general the energy managements, are evolving, and what are the roles of smart grid and Internet of Things in terms of energy management and how it helps. And then I will share some of the home energy management systems. We call it a little bit smarter home energy management system that we developed in UAE University. And then finally, we have future trends in home energy management system. That means it's going to be more smarter than current energy management system that are used in residential households. And finally, I will give conclusions of our finding in this session. Yeah. First of all, with the invention of electrical generators and electric bulbs, electrical energy become the main popular source that are used around the world, because it is easy to use, it is clean, it is easy to transport from one place to another. In the meantime, it can be easily converted from one form to another: electricity to heat, electricity to light, electricity to any other form of energy. So that's why it became very popular after the invention of electrical generators and the other devices that work on electricity. With that, the consumption of electrical energy drastically increases because of industrialization, as well as the growth of population. As you can see in the first figure here, the electrical energy consumption in 2018 is more than 22,000 terawatt hour, and it is expected to increase to 31,000 terawatt hour by 2030, and it is still keep increasing. At the same time, as we know that the depletion of fossil fuel is happening around the world. At the same time, greenhouse gas emissions and carbon emission is increasing as the days goes on. So with that, in 2016, OPEC countries and some other non-OPEC countries make an agreement to cut oil production and then to maintain the global oil price. With this, it actually affects the price of electricity and in every sector, in industry, in transport, and in other buildings, including the residential customers. So as you can see, there is no growth in the middle figure. There's no much growth in the fossil fuel, and most of the oil is produced in the Middle East. So there is a limited resources in the terms of fossil fuel. Because of that, in the future, by 2050, it is expected to reduce the dependency of fossil fuel and increase the production of more sustainable energy, such as PV, photovoltaic energy, wind, and other variable renewable energy sources. So from the third figure, you can see by 2018, there is a very little renewable energy, so that sustainability is not much, but we are expecting that renewable energy sources will increase and dominate in the electricity mix. In 2000 to 2060, 2017, there is an increase of 25% of renewable energy in the electricity generation mix. So you can see in the third figure here, so the main portion that is contributing in terms of renewable energy is solar and then the wind. And tidal energy is also one of the potential energy sources. And I'm going back to the first figure here. We can see that the industrial demand of electrical energy is not increasing that much. However, we can see that electricity demand due to the buildings are increasing day by day because of population increasing, development of new cities, and so on. In the meantime, you can see that it is being increasingly nowadays used for transportation due to the introduction of electrical vehicles. And it is expected that transportation sector will also consume a lot of electrical energy and reduce the dependency of fossil fuel in the future. So now I'm going to give you some information towards the residential energy consumption. So you can see here that residential energy, we are talking about homes or houses or villas. So in these residential compounds or houses, there are few things that consumes electrical energy. Among these, cooling and heating contributes 47% of energy use. Water heating consumes about 14%, dishwashers and dryers, 13%, lights, 12%, refrigeration and other devices, they consume a very small amount of power. So which is actually between 3 to 1%. When you look into the bottom figure on the right, we can see that the energy consumption in residential units or homes depends on country to country. USA and Canada are the region where there's a lot of energy consumption at home, which is about 11,000 kilowatt hour per hour. But in general, around the world, every household consumes about 3,000 kilowatt hour. So among this energy consumption, as you can see, there are some energy hungry devices, and there are some other devices that is not using so much energy. So we can see here in the home, there are many devices, and actually all the energy is not effectively used. Only 65% of energy is used, and other 35% is wasted. So you may think of where this 35% goes. So mostly it is going because we do not use electricity efficiently. Maybe it is going to the computers or other electronic devices that are working in standby mode. Or maybe it is because we set our air conditioners or heaters to a wrong or to a wrong temperature set points. So this is quite difficult to handle. That's why a home energy management system is required. Yeah, so the current problem is actually because you know that electricity is demand is increasing day by day, and there is a trend of consumption. So in the daytime, usually it is higher compared to the evening time. And again, it depends upon the industrial load and where people work. So in UAE, we have a situation that the utility encourage us not to use electronic equipments or devices between 1 p.m. to 4 p.m. This is because at that time, the demand of electricity is very high and may cause some problems or constraints to the utility grid in terms of voltage variations, power loss, and also the harmonics. And another problem that we are facing right now is that in our offices, the air conditioning systems are centralized. And during the weekends, the air conditioning systems are not performing at its in regular days. So we need to inform the authorities who manage the buildings before we go to work so that they can adjust the temperature in our buildings. And again, this is just to save the energy manually. So this is again another reason why we need to effectively manage the energy in our buildings and in our homes. Then when we look into reduce the energy consumption, we need to do some calculation, or we need to know how much energy we use in a day or in a month or in a year. So at the moment, there's no much easier way to see that. For example, in UAE, we have some sort of application provided by the utility companies to estimate the energy consumption during the month. So in this system, you need to enter the devices or appliances you have in your home and see how many hours you are using them, so that it can calculate and show you what is the kilowatt hour per month that you are going to use approximately. And this is not an easy and very manual system for people to manage. Okay, so these are some of the problems. So now I will talk about the evolution of home energy management system. So as I talked before, electricity price is increasing because the oil prices are increasing. At the same time, the production of energy from renewable energy systems are not actually that much at the moment. Because of that, we need to optimize the energy use at residential level or other sectors as well. With that, for optimize the energy usage, you can have different systems. For example, you can have a solution by using passive methods, or you can have a solution with active methods. Passive methods means that you are replacing some of your old devices with some other energy efficient devices. Then you have active methods that needs the feedback and a control system to manage the energy. Then comes the smart home energy management system. This is the current status of home energy management system, where we have smart things included in the management. We are interacting with the utility, interacting with the customer, as well as we are interacting with the devices that are available in the buildings or at homes. So this is current, and we have a future trend as well, which may further improve the use of energy at different level and make a sustainability of energy in the future. Okay, so in the beginning, it started with some simple things for energy management. I think you might notice that in some notice boards or on the walls of your offices, you will find some notice like this: save energy. Please turn off your light before leaving your room. So that's where it begins the home energy management system. This is because we need to save energy and reduce our electricity consumption so that our carbon footprint can be reduced. So the next level of energy management comes with the energy rating. I'm not sure how many of you are familiar with the energy rating. You might notice when you go to buy some electrical appliances that are used in buildings or homes with the star rating. So star rating tells you how efficient is your devices and how much energy it consumes. For example, this is 2.5 stars. That means it's not a very efficient or a very efficient device. More energy efficient devices can be found with a 4-star rating or 5-star rating. So in addition, this type of stickers that are found on the home appliances and devices, you will find also how many kilowatt hours it consumes per year, approximately. So in this case, it consumes about 458 kilowatt hour per year. So you may look when you want to buy a new appliances for similar specification to have a more stars. So if you choose a device, for example, a refrigerator, a washing machine, air conditioner, you can look for a device which has more star ratings. So that this comes under the passive methods to improve and reduce the energy consumption at your homes. And then the next transition from these marks comes with the more energy efficient devices come to market. Among this is the LED lights. I think now everyone uses LED light compared to a few years back. Before, like 5-6 years before, the most dominant type of lighting system is fluorescent lights. And before that, before like 15 years, they use incandescent lights. So you can see that the energy saving, for example, for same lux level, for the incandescent lamp is 45 watts, but it can be further improved in terms of energy and provide the same light with the energy consumption of 5-6 watt if you use the LED lights. And again, the price of those lights have reduced tremendously in the last few years. At the same time, there are many other devices that are more energy efficient nowadays. So now split type air conditioning systems are now being replaced with inverter-based split type air conditioning system. As well as in the cooking, you have induction cooking, which is more efficient, and also we have inverter-based washers, dryers, and so on. So if you replace this, of course, you are managing your energy at homes or in your building with passive devices. Then some form of automation comes in. So we call it home automation systems. So you might introduce motion sensors, you might introduce temperature sensors to see and to turn on and to turn off the lights, or you can use it to control the temperature in the room as well. So this is how the home energy management system evolved, starting from high energy price. People want to reduce it, so that they introduce awareness programs, they introduce a new, more efficient devices, and they introduce a little bit automation through sensors in the system. Then smart home energy management system or home automation system came in the market with more than 800 million in 2016. And it is expected to grow to 3.5 billion by next year. So for sure that energy management system are going to grow in the future, and hopefully everyone have a smart home in the future. So the main key players in the industry of home energy management or building energy management system include the Bosch. These are the brands that are working on an ABB company, Honda Home Automation Systems, Schneider, Samsung, Google. They all are in the market to provide solution for their customers and make the homes more energy efficient. There are different types of ways to do it. One is through the wired system, and then wireless systems, and or combination of those. Fibaro is another company that is only involved to change the existing buildings to automate using the wireless networks. So that's where the Internet of Things are coming here. Okay, so next, what is the role of smart grid and Internet of Things in home energy management system? So smart grid is a new technology recently introduced for the purpose of increasing sustainability of energy consumption. What it is doing is it's responsible to the rise of energy demand and to reduce carbon emission so that it preserves the environment. So that's the main purpose of the smart grid. So there are 4 features that are very important in smart grid technology, which is it ensures reliable and high quality energy on demand. It builds the capacity to cater adequate increase of demand of electricity. And also the third point is much related to our topic, which is it tries to increase the efficiency in power generation, distribution, transmission, as well as energy consumption. So from these 4 items in power system, generation, transmission, distribution, and utilization or consumption, the consumption part is where demand side management comes in. And then, of course, it also promotes sustainability through the integration of renewable energy resources. And as you know, currently, many building integrated photovoltaic systems are included in the buildings, as well as the electric vehicles. are coming in the picture. So what actually smart grid gives you is that it allows you to interact with the utility and helps you to manage the energy more efficiently than before. So in the case of smart grid system, they introduced a program called the demand response program. So it is defined as changes in electricity usage of customers from their normal consumption pattern in response to changes in electricity cost over time. Or it creates incentive payments for the customers to lower the electricity use during the time of high demand, so that system can be more reliable. Okay, so in the case of demand response, as you can see, there are two categories. One is price-based programs, and then the other one is incentive-based program. So the price-based programs can further be reduced into two parts, which is time of use price and real-time pricing. And then you can also have a peak time pricing and also the critical load pricing. So there are many different schemes where the customers can participate in the demand response. Another one is the incentive-based. This is direct load control program or interruptible curtailment program. So direct load control means that the utility can interact with through the internet and control their loads, manage their loads. On the other hand, the utility have the ability to interrupt and curtail the load so that the demand can be controlled from the utility side. Another one, they introduced something called demand bidding. So demand bidding means that you can try to, for a price, you can reduce or you can cut the price, the demand, so that the customers can get some incentive, because who is providing the lowest reduction with the price, then they will be given this incentive. Yeah, so those are the demand response programs, and this is actually where the home energy management system can become smart. Without that, it's just home automation systems. Okay, so what is home energy management system actually? It is a technology which includes both hardware and software that allows users to monitor and control the energy use based on the demand or based on the price of the electricity. Okay, so we can see that with this home energy management system included with the demand response program, we can actually customize and control our devices more effectively to reduce the energy use and reduce the carbon footprint, as well as to reduce your energy bill. So this is the bottom figure shows a typical home energy management system, smart home energy management system, where you have interaction with the devices. You get information from the smart meters that are connected to the utility. And then you get the weather information from the internet. You can get the occupancy information from the system. And you have the smart devices that are connected to your home energy management system or central controller, which is again linked with the renewables connected to your home. So all this interaction, bi-directional communication, helps you to do a better energy management in the system. Okay, so I will move on. What are the main devices that we have in the home energy management system? Home energy management system basically consists of hardware, software, and then energy portal, and then the monitors at home. These are the main items that are involved in the home energy management system. So the first one is the hardware. Of course, this is the most important thing that you want to control. Normally consists of a device which serves as a platform upon which the communication between user and household appliances and devices are confirmed with this one, and you can interact through your devices to your appliances either by communication medium, which is wireless, or it can be physically wired through the Cat5 or Cat6 cables that are integrated with electrical boards or power sockets in it. So you can control and monitor with that devices through this medium. Then you have the software. Of course, the software is a very important component in the home energy management system. And it is responsible for moderation of incoming and outgoing data and communication. It allows interface with users and allow access to monitoring and control function of home energy monitoring system. Among these softwares, here I just listed some of the main softwares that are commonly used in the home automation or home energy management system, which includes IO Broker, Event Ghost, Open Hub, Castle OS, and Creston. So these are the common softwares that you can integrate with the hardware that is available in the market. You can buy from different companies the hardware. It can be from Samsung, it can be from Google device, or it can be from ABB device, or a Fibaro system device. You can integrate all these hardware through some of these softwares. So the software is very important part in the home energy management system, and you can make the system more intelligent through the software. Then you have the energy portal. So energy portal is again important. It can be as normally integrated with existing hardware, with such as smart application or utility meter that can collect and transmit information. So here in the figure, you can see that user interface products such as energy portal. It actually gives you information about what you are doing in a day, which you usually do not have in the past. So you can see that at what time you open the garage, the roller shutters, when you turn on the lights, when do you iron, and so that you can manage your schedule based on this and how much energy is used on those appliances. Now this is common. If you look into the other Internet of Things, you can see that, for example, Google Map. So the Google Map if you have installed your Google Map application in your system, you see that after every week it gives you information which places you visit, how frequent you visit. So it's kind of similar to that, but applied to the energy use in the home. So you can actually get an idea about how you are using the energy at home. Maybe you can also control more effectively by using this information. Okay, then we have home display items. So this is actually the console that you found, for example, just like a CCTV, a console that you have in your home to see the people coming from outside and talk to them. It's something similar to it, and it provides a real-time energy use to the homeowner, so that it can prompt your energy use, what is going to happen, and what is the temperature, how do you set the temperature, and so on. Give a notification on the peak demand if you set a point. So those are the some of the items that you have. And again, the last one, is the load monitor. So load monitor is something like a device which tells you which load is on, for example, and at a certain given time. So it's a device that is in between the power source and the device, and giving some information about the customer, about its use, and collect the information from those devices. Sometimes it allows you to control the device as well, depending upon how smart is your devices. Okay, so basically I give you right now some information about the components in the home energy management system, what makes the smart grid and Internet of Things to make the home energy management system smart. So it's through the demand response application and information from weather conditions and the occupancy conditions that makes the system more smarter. Okay, so now I'm going to talk a little bit about what we did and what we still keep doing, improving as a home energy management system in UAE University. Okay, so here we have some inputs, which is the power monitoring from the devices. That is the one that I explained, energy monitor. We also have the occupancy monitoring, condition monitoring, and then we need to get information from the smart grid about the time of use of price of electricity. So with this, we try to have a little bit the smarter system for home energy management. So the important things are like monitoring the power consumption, occupancy monitoring so that you can turn off the device if nobody is there. Condition monitoring is required to see the temperatures, lux level, and so on in the building. And of course, we need to know the price of electricity so that during the high price time, we can lower the energy consumption in the home. So we try to develop a prototype home energy management system and develop an algorithm or coordination algorithm for making the home energy management system a little bit smarter than just normal home automation system. So for that, we need again many things to do that. We need softwares, we need hardwares. For our case, we use Arduino microcontrollers and develop a wireless system through the Zigbee communication medium. So first of all, we have Zigbees. This is a mesh network with multiple Zigbees that are working and connecting as a mesh system and giving information to the control. So you need to set the communication from your Zigbee modules to your central controller. So you define the plug and play device information. Once you plug in, the central controller can detect it and identify the device. So that's why XCTU is the platform. We configure all the devices that we develop. So for that, again, we have to use other softwares to do the hardware, like deep trace to figure out the circuits, conditioning monitoring circuit, the power circuit, smart socket, and so on. Okay, then of course we have to code all our microcontrollers like Arduino. We can use the Python codes for this purpose to make the energy monitoring from your devices, and also make the wireless communication suitable. So these are the softwares that we use in our system. And of course, we develop the things around those softwares. We design the PCBs, we use the different microcontrollers, Zigbees, current sensors, voltage sensors, and so on. So this is one of the devices we develop for as a smart socket. Then, of course, we have the room condition monitoring. We need to know about the occupancy of the system. We have to know about the temperature. We have to know about lux value in the room. So we have to develop this condition monitoring system as well. In our design, we do not include the thermal cameras in the room occupancy monitoring. Rather, we use the CO2 sensors and the motion detectors to identify whether there is a person in the room or or the rooms are vacant. Again, we need to code all of these, and then we have to use the Zigbee to transfer the data from this device to the central controller. Okay, so in the same time, we develop all possible devices like light dimmers. We can control and we can ask the lights to reduce the intensity by giving some commands through the wireless module to the controller of the lights. At the same time, we have also developed the universal remote controller. So any of your home air conditioners can be programmed through this infrared reader for turning on, and all the codes can be programmed inside this, and then you can control wirelessly to your air conditioners. So these are the main items that we develop because the air conditioners, the heaters are the main elements actually that contributes to the reduction of energy. So first we did some testing, see whether power sockets can accurately measure the power and see whether it can be used for that purpose. So here are some tests that we did. Device connected to the different items, and you have a central controller to monitor it. And also we use the power quality analyzers to see whether our readings are accurate or not. So these are some of the comparison with the power quality analyzer readings and this smart socket that we developed. So it gives almost the same data so that we can verify what we are measuring is correct. Okay, then we also tested whether we can control multiple devices through these smart sockets. So we have air conditioners, we have blenders, microwave kettles, and so on were used in the experiment. So we have this, we can control wirelessly all these devices simultaneously. And then the total power consumption from the 3-4 devices sum up to be the same, and the what we measure at the distribution panel is the same as compared to the actual value. So that's the verification part. And after that, we try to make the system smarter. For this, we need to predict the time of use price in the future so that we can develop an algorithm to act based on that. So we use the artificial neural network and get historical data. Based on historical data, we identify the future time of use price. So from there, we can identify which hours the prices are high and which hours the prices are low. So this is very important for smart home energy management system to predict what is the prices at different time. And with that, you can actually reduce a lot of energy. Yeah, so for example, this is for one day, the electricity prices at different time of the day. This is just an example where you have a valley in the early morning. So the prices are very low, and around 3, 4, 5 afternoon, the prices are quite high. So that means this portion you should not use much of the energy, and you should try to utilize most of the energy hungry process during the day, early morning. Yeah, for that we have tried to apply again different system. We use the refrigerator as a device that can be controlled, air conditioner, water heater, and the lighting system. So this is the experimental setup we use for the refrigerator control. It measures the internal temperature and also measures the power as well. So this is the air conditioner that we use in our room, actually, consisting of all these monitoring and controlling. And we have the heater also monitoring the input temperature, output temperature, and then you can wirelessly determine when to use it. The light dimmers are the same that we use here. And then based on those and the customer preference for the temperature settings, the light settings, we make a rule-based algorithm. So based on these rules, you don't need to turn on or turn off, but it will try to act based on the rules that we develop in the algorithm. So these are different rules for the lights, for air conditioners, and the other devices. Okay, so you can see that energy management system for the lights, when the energy price is very high or the ambient temperature is, ambient light is high, then you don't need to brighten up your light so much. But if the environment is dark, you need to make the light more brighter. So with that, the power consumption will also increase. All right, so, and then when people are not there, of course, you should turn it off. So similarly, we can manage the power from the air conditioners. So usually when you have air conditioners, when you set a temperature from your thermostat, it will maintain at that level. It will never change until you change it. So in our system, we see that we have a band of the temperature it should be between 24, 25 when people are there, and it can go to a lower value when the prices are lower. And when nobody's in the room, you can turn it off so that the temperature keep increasing. By the time that people arrive, then it should reduce, and if it's a peak time, it should not go to a very cold level, but a comfortable range that is set or given by the user. So in this way, you can actually manage these devices accordingly. So similar to the other devices, the refrigerators and others, and the water heater as well. So with that, when you look into the energy consumption in a day, you can see that after using a scheduler or intelligent system, the amount of energy that you use can be reduced to a very lower value compared to the normal one where you do not take any action. A lot of reduction is observed in our experiments because we have an air conditioning system. It is left by the users to set it to 20 degrees, and because of that, it consumes a lot of energy. But with the use of energy scheduling algorithm and the devices, the energy consumption reduces a lot. At the same time, the price, of course, will reduce because we have a very high price between 3 to like 7 o'clock. So at that time, the energy scheduler or smart system try to reduce the use of energy during that time and try to use most of the schedulable loads like washing machines to the early morning. Yeah, so that's what we did, and we are still working on it to make it web-based through use of Internet of Things. So we can, instead of using the controller through your PC or a device at home, we can take it to a next level. All right. Yeah, so here is some of the pros and cons of the home energy management system. Of course, it allows homeowners to smartly manage their energy. It provides more comfort to manage the energy because you do not need to worry whether you turn off your lights before you go on. You go to outside or you left to the office, so that part will be not there, and by the time you come, your room will be cool enough as well. You can actually save the energy as well by using the system. And you can make the system more efficient as well. Of course, by using this smart home energy management system, you know how much energy you use, so the visibility, the trend of energy, you have it in your mobile phone or in your house monitor system, so that you can try to achieve a better goal in the using the system. We can actually use renewable integration into the system by based on the availability of the light and the power from the PV modules, and also we can integrate reduce the reliance on the grid. So these are some of the pros of the system, but of course there are some limitations as well, because first limitation is, at the moment the home energy management systems are costly, so that everybody still cannot afford the system. And another one is that everybody is not very much familiar with the home energy management system, how to use it and what benefit it can bring. So that's another issue about home energy management system. The third one is the privacy issue, privacy and cybercrime. So since you are giving more information what you do during the day, so if your system can be hacked, then the people will know when you are at home, or how you use the energy, what time you come to home, or what devices that you are using. So this information is actually not good to be public. So that's some of the main cons or the disadvantage of the system. And again, it is not that simple at the moment. You have to do some set points for you to identify your comfort levels, so that these things people do not like to have at the moment. So what is coming in the future is, there are a lot of works going on in the home energy management system, which includes the integration of the renewables, building integrated PV systems, use of more efficient cooling systems, lighting systems, and so on. And also use the storage devices, which is mostly electrical vehicles coming in. So you can basically store the excess energy from the rooftop PV systems during the day, and then you can use it when the prices are high. So that actually is the future trend. And in terms of intelligence, now self-learning methodologies are coming based on previous history. You don't need to have a rule base, but you can allow it to learn by itself how the homeowner uses it and schedule based on that. If you look into this video, actually the link is here. It shows you what Honda is doing in US to have a smart home energy management system. So in the US, Honda home energy smart home systems, they are integrating and building the home infrastructure, including the Honda electric vehicles and rooftop PVs and other technologies incorporated. Since we do not have much time, I'm not going to play this video, but the link is here. Always you can have a look at it. Okay, so my conclusion for today is that home energy management can reduce the overall energy consumption by scheduling home appliances without affecting customers' comfort level. With the use of an optimal scheduling controller, participating customers in demand response program can reduce electricity bills they reduce their electricity usage during peak period and shift peak time load to off-peak times, and thereby reducing the carbon footprint. So HEM system will be an integral part of the smart grid in the future as a demand-side management problem. So already there are many research work is going on how to manage the demand side. So that means multiple homes are combined together to provide demand side management and use the system more effectively. In the future, all the home appliances will be Wi-Fi connected, and then you can control your devices through your mobile phone. The scheduling can be done through your phone, and for this we need to have the Internet of Things, just plug and play mode to have every device is connected and controlled through your application. So this, we already started doing the application through your mobile phone, and you can control your home appliances from anywhere in the world. So that's the current research work that we are going on. And thank you very much.
Thank you, Prof. Hussein, for the interesting talk. On behalf of the organizing committee, I would like to thank Prof. Hussein Sharif for the very informative talk. I believe all of us understand the main points from the talk just now. Now, I will proceed with Q&A session. I will read the questions from...
Yeah.
Where
the increment of tariffs. Oh, I did not get the question very well. Of course, the tariffs are increasing, depends on usually the oil price, just like the petrol every day is increasing here, and we have a different scheme in UAE for different customers, and every year the tariffs keep increasing.
Okay. The next question is from Hazli Mokhlis. Thank you, Prof. Hussein, for the presentation. In UAE, does time of use tariff has been implemented? If no, any plan to implement it? If it's done, if yes, how does it impact customers so far?
Right now, the peak pricing has been implemented. So for the industrial customers, the peak price are different for the daytime, and between 3 to 5 it is different. And also in Abu Dhabi now, the residential home complexes, usually they have a big complexes, means that what can I say, in Malaysia there's the tawans, right? Tawans, where there's a lot of houses managed by a single company. So they are introducing this smart metering technology, and they try to implement it, this system for the users. But I'm not sure at which time they are going to implement for the residential customers.
Okay, I will pass to Dr. Farid if he want to ask questions to Prof. Dr. Farid.
Okay, Prof, thank you for your very interesting sharing presentations. I have a few questions regarding your monitoring device. Have you engaged with any policymaker at UAE to get approval or to get endorsement from them? Because basically we need to deal with them first before we burst or we allow the customer to use that kind of the device.
Yes, of course, there are many government agencies that are involved with this type of things. So usually for the communication, what is happening right now is that we try to introduce the technology for the main players. Like here we have telecommunication company, then which is Itisalat, and the Minister of Energy, that is the policy maker, to come and sit with and see whether this kind of thing can be implemented and get in their inputs for the future use. So we have also like Energy Authority actually from Abu Dhabi. They are responsible for making policies and allowing this licensing.
Okay.
And of course, we need to incorporate the communication company. Basically, there are only two communication companies here. One is Itisalat and one is Jood. So Itisalat is the main provider for the communication here. So they should be included when something big like this is, if it's going to happen.
Okay. Second questions, a little bit technical, based on your device again. What is the sampling rate that being produced for your monitoring device? The sampling rates.
Sampling rate. Sampling rate is 6,400
Okay.
hertz. Or in a 50 hertz cycle, you get 128 samples per 50 hertz cycle. If we
Okay.
go below this sampling, actually you cannot easily accurately monitor the power. But of course, the information is in the beginning is stored in the microcontroller of the device, and this being sent to the central controller every second.
Okay. That is all for me.
Okay, the next question from Nadia Tan Meli. Thank you, Prof. Hussein. Can users actively set the schedule for HAMS, or is the HAMS automated and customers need not be actively involved?
Yeah, so the GUI we have in our system, it is actually automatic after you give your comfort ranges. So comfort ranges means that you have to mention that what is your preferred room temperature, for example. Okay, so if you say that it's 20 to 25, yeah, then the controller will try to maintain the temperature within that. But of course, if you want, you can override it. So that's what is we have at the moment. Did I answer the question? I guess I answered the question.
Okay, all right. I think that is the last questions. I would like to thank Prof. Hussein Sharif for answering the questions from the participants. Before the program ends, we would like to inform that we have provided a link to answer the quiz in the chat box. The quiz is based on Prof. Hussein taught just now. The quiz will be closed 30 minutes from now. For the quiz, we will announce the winner in the IEEE UiTM-SB website and e-certificate will be given to all participants. With that, we have come to the end of the program. I hope all of you could support all of our upcoming events. Please follow the IEEE PES Malaysia and IEEE UiTM Student Branch Facebook, Instagram, and YouTube. Stay safe, everyone, and Assalamualaikum warahmatullahi wabarakatuh.
Walaikum salam, and thank you very much.
Thank you very much again, Prof.
Thank you.
Thank you,
Okay.
Prof.